In a previous video, I reviewed the Ender 3 V3 KE, and in that video, I teased some upgrades that I had planned for this machine. One of them was the spool stand, which is now available. I'll put a link to that in the top right corner of the screen. And it has addressed the spool being mounted to the frame at the top, leading to excessive shaking. The other upgrade I mentioned was a linear rail upgrade, which I've seen a few other people do now. It was originally intended to fix some of the instability issues of the Y-axis that some other users experienced with their KE. I tested a few linear rail designs, but I found that many of them relied on too many printed parts, and there's just more opportunity to install something incorrectly and introduce even more variance. Switching over to machine parts would increase the cost to the point where it would barely make sense, so I started to look for other solutions. It occurred to me that the newest Ender 3 V3 Core XZ machine uses thicker 10mm rods, and it prints beautifully. The larger rods are stiffer and they offer more bearing contact area, so I found a way to adapt them to the KE and SE models, and we'll go over that in this video. I've seen some users report that the original 8mm rods were undersized or had poor bearing clearances, premature bearing wear, etc. Now I've got 3 of these KE machines and none of them had those particular issues. However, 2 of my KEs had some strange bed mesh issues that I was able to fix with these larger rods. Ultimately, I found it was a great balance between price and performance with the added benefit of very simple installation. The rods utilize the original mounting locations, so there are no concerns about using FDM printed parts. The only parts that were printed in this kit are actually multi-jet fusion nylon, so they're extremely precise and robust. So let's dive into getting some better results from this machine. As I just mentioned a moment ago, I own 3 of these KEs, and so I've grabbed one of the machines that's been completely unmodified with the exception of the spool stand. I'm going to establish a baseline bed level mesh for this printer, and to do that, I want to just first make sure that the bed itself is tight and secure. In my review video, I noted that these screws oftentimes come loose after some period of use, so I ensured that they were tight before running the auto bed leveling and establishing our baseline bed level mesh. I just wanted to make sure that this wasn't going to contribute to a poor mesh and any sort of Y-axis instability. So with that done, I can now run the auto Z offset as well as the auto bed leveling procedure. Now I do have this printer rooted, so I can open mainsail and take a look at the height map that was generated from the auto bed leveling procedure, and this is the result. As you can see, it's not looking so great. Over on the right hand side, under range, you can see there's a maximum range of almost 1.6 millimeters. We can toggle the button under the mesh to scale the gradient appropriately. And I can see the gradient to the left of the mesh has the proper scale to it. At first glance, it looks very twisted. There's a pretty noticeable difference between the front right corner of the bed to the back left corner. Now we can break this out into 2 separate components, left and right and front and back. And I think I have a solution for the left to right. But first, let's address the crooked hot end. Now this seems to be a pretty common theme on these KEs. I addressed this in my previous video, which you can see here. So that machine had the exact same problem, and in that video I showed you guys how to address that. I'll quickly replay the procedure here in this video so that you don't have to go skipping around YouTube to find it. And basically you're just going to remove the front cover from the KE. There's 2 screws on the right hand side, 1 M3 on the left hand side, and the cover will simply slip off. Now you can remove the silicone boot from the hot end, and it might be stuck on there pretty good, so you will have to pry fairly hard. Be careful not to rip any wires off with the boot. And you'll see 2 small screws to the left and right of the hot end. I've just loosened these off. From the factory, I believe they just over tightened one side and caused the hot end to be crooked. And once I tighten them back evenly, this straightened out my issue on the first printer, and the same process worked on this machine here, featured in this video. Now this likely won't have an impact on the bed mesh, but it's worth doing because it will probably fix any issues that you might be having with your auto Z offset. The other common issue I've seen with these machines is a crooked gantry. So you can see I've got 2 metal blocks that are the same height on the left and right hand side underneath the gantry, and there's a bigger gap on the left hand side than there is on the right hand side. The print bed is not on bed leveling knobs, so you can't make adjustments to the print bed. So what you have to do here is you have to make the adjustment to the gantry. And again, these are clips that I pulled from my review video. So this is being shown on the first machine that I got, And I'm also going to do the same procedure to this machine in this video. But essentially you can take two items of the same height. So again, I'm using these metal blocks, and you can go to the back of the printer and look at the timing belt on the Z-axis lead screws. I would loosen the grub screws on the side of the printer that is higher than the leveling block. Then you can hold the lead screw still on the side that is resting on the leveling block, and the one that's higher, you can manually turn it until the gantry is now resting on those leveling blocks on both sides. Once you have both sides of the gantry resting on those blocks, don't forget to tighten up the grub screws on the pulley, and you're all set. It's probably best to do this procedure with the machine off so that it's easy to turn the lead screws and the motors aren't locked. And this should resolve that massive left to right hand side discrepancy in the bed mesh. So I'll go ahead and run that procedure again, and we can take a look at the results. And again, I'm using Mainsail in my browser to view the height map. And you can see now that there is much less twist, so much less left to right difference in the bed mesh. There's still a total range of about 0.675 millimeters. This is much better than 1.6 millimeters that we saw initially, but there's a curious slope from front to back on this mesh. After performing the gantry leveling, this is actually something I've seen on one of my other KEs as well, and I was never able to really pinpoint or say for certain what is the cause of this front to back slope. I previously measured the spacers underneath the print bed, and they all check out. There's definitely not that much of a difference between them from front to back, so I ruled those out. But regardless, at least at this point, I've taken the crooked hot end and the crooked gantry out of the equation. Now that we have the printer set up properly, let's see what we can gain from upgrading the Y-axis rods. So the first thing we need to do is move the gantry up and away from the print bed, and then we can remove the flex plate. Then we can turn the machine off, and you'll see the print bed is free to move, and we can remove the 4 screws holding the print bed down to the print bed carriage plate underneath. During this process, the black plastic standoffs will likely fall out. Be sure not to lose those, as we'll be reusing them later. And be careful not to pull up on the print bed too quickly, as there will be one electrical connector underneath that needs to be removed, and you don't want to tear this thing out. Carefully disconnect it by hand, and then you can gently push the print bed back through the frame and set it down on its side beside the machine. You'll need a Phillips head screwdriver to remove the 2 screws holding the PCB to the Y carriage plate, and then you can just leave that sitting there, because next you'll need to remove 10 of these M3x10 socketed cap screws. There are 4 holding each of the 2 bearings, and then there are 2 in the middle that are holding the timing belt bracket to the bottom of the Y-axis carriage plate. The carriage plate can now be removed, and at the front of the machine there are 2 of these M3 button head cap screws that we can just loosen off. At the back of the machine there are 2 more M3 button head cap screws that you'll want to completely remove, and these ones you do not want to lose, as you'll be reusing these in a moment. Now we can remove the original 8mm rods, and you'll see that they'll slide back and forth, and you can just slide them towards the front of the machine and then lift them up and pull them out. With everything out of the way, it's also a good opportunity to clean the top of your machine. Now we can grab the new 10mm linear bearing holders, and you'll see that there is an arrow on them on the top side. We'll get to that in a moment, but for now we'll just take our bearings and we'll push them in towards the back. You'll see that there is a shoulder and a relief. You'll snap them into place. You want the bearing butted up right against that shoulder, and 2 of them should fit side by side very snug. And if you've purchased the right bearings, you'll see that there's no movement forwards or backwards. These parts are nylon PA12 made from the multi-jet fusion process, so they're quite robust, and they'll hold those bearings nice and tight. So you'll complete the second side, and now we can move on to the rods. So the rods here are 10mm linear rods, and on the 2 ends you'll see that they've been machined down to 8mm. On the one end there is no hole, and on the other end there is a threaded hole. I'll be giving mine a quick cleaning before installation, and for this I'll just be using some 70% isopropyl alcohol and wiping them down. Installation is extremely simple. You'll take the end with the threaded hole, and that will be facing the rear of the machine, And we'll be grabbing our bearing holder with the arrow, and we'll be pointing the arrow towards the rear of the machine. Insert the end of the rod closest to the front of the printer first, and then lay the rod down flat and slide it towards the back of the machine. And then we'll repeat the process for the other side. So again, the end of the rod with the hole in it will face the back of the printer. The arrow on the bearing holder will also face the back. And then you can insert the rod, and we'll be securing it at the back of the machine with the original M3 button head cap screws that were removed from the original 8mm rods. At the front, we'll be removing the original M3 button head cap screws, and you'll be replacing them with these slightly longer ones that are included with the kit. So these will be M3x6 button head cap screws, and you'll see now that when we go to tighten them and they actually butt up against the rods, there'll be a small gap between the head of the screw and the machine. So we know that these are now touching the rods, and the rods should be secured in place. Now we can bring back our carriage plate, and we'll be carefully placing that on top of the bearing holders, and we'll be reusing the M3x10 socket head cap screws to secure the plate down on those bearings. I would suggest getting all of the screws started before fully tightening any one of them down. Once they're all threaded in, then you can work your way around each screw and do the final tightening. Then we'll take our last two M3x10 socket head cap screws. Again, these are the originals from the machine, and we're going to be securing the timing belt bracket to the bottom of the carriage plate. I'm using my finger to hold the bracket in place underneath the carriage plate so I can get the holes lined up. I can start threading the screws in by hand, and then I can give them their final tightening. With the motion system reassembled, you should be able to move the carriage plate back and forth freely. It should not feel like it's binding, and it should also not feel loose or wobbly. Now we need to secure the PCB back onto the bearing holder on the left-hand side. And to do this, in the kit, you'll find these M3x10 thread forming screws, and those will just get threaded into the top of the left-hand side bearing holder. Then we can bring our heated bed back, and you'll want to plug the connector back into that PCB. Then we also need to grab our 4 plastic standoffs. You'll see that 2 of them are shorter, 2 of them are longer. The 2 short ones go on the left-hand side when you're facing the machine from the front, and the 2 longer ones go on the right-hand side. This is extremely important, otherwise your bed mesh will be a mess later on. Then we can put the 4 countersunk screws back in place through the top of the heated bed. You'll need to carefully guide them through those standoffs and into the threads in the carriage plate. This is probably the most annoying part, and you'll likely have to mess around with the one in the back left-hand corner, where one of those shorter standoffs sits between the bed and the strain relief for the heated bed. Get them all partially threaded in before doing the final tightening, and now the heated bed should be secure, and we can replace the flex plate. If you've done everything correctly, you should be able to move the print bed to the back of the machine and hear it engage the rear limit switch without any obstruction, and at the front, the carriage should clear those longer button head cap screws that we installed. Creality KE comes with some PTFE grease. Hopefully you still have that. If you don't, I would recommend some PTFE based grease to lubricate the rods. You can apply some to the front and the back, and then we can turn the printer on, and it's time to rerun the automatic Z offset as well as the auto bed leveling procedure. And as we've done before in this video, we'll hop back into Mainsail and we'll check out the height map tab. And you can see here that our bed mesh has improved again considerably. This time we've got a maximum range of 0.25 millimeters, and that's pretty respectable. You can try and improve that even more by shimming the bed, but at 0.25 millimeters, the machine can easily compensate for that. So why did the new rods seem to make an improvement to the bed profile? Well, when I take a look at the original 8mm rods, when I roll them on a flat surface, they seem to roll pretty straight, but when I put the two side by side, they seem to diverge from one another just a little bit. And if I try to keep them in contact and roll them against one another, you may be able or may not be able in the video to see a little bit of light pass between the two. So I'm speculating that the original rods may have a slight bend to them. This may have been pitching the print bed forwards or backwards slightly, leading to that slanted mesh that we saw before the rod upgrade. Let me know what you guys think down in the comments section, but either way, the new rods seem to have fixed that problem. So now that our mesh looks good and we've got the rods and bearings installed, we're just going to perform a simple first print. So we'll check that bed mesh. And I've just got a single layered print spanned across most of the print bed here. And the first corner is going down extremely smooth and uniform. And while we wait for that print to finish, just a reminder to check out the universal spool stand that is fully compatible with the Creality KE on my website, embracemaking.com. And a few moments later, we can see that the print has finished, and this is looking really nice. Now that we've sorted out the crooked nozzle, the Auto Z offset would give us a much more accurate result, and I did not have to make a single adjustment to that while that first layer was going down. Combine that with our vastly improved bed mesh, and we get a perfectly uniform first layer print. Unfortunately, I did crease the top left corner of that a little bit as I pulled it off the print bed and dragged it across the print head, but otherwise it's flawless. For comparison, I pulled this clip here from my original video on the Creality KE, and you can see with a much smaller print, there is a lot more variation in that first layer. And this would have been the printer probably trying to compensate for that original bed mesh with over 1.6 millimeters of variance. So we've definitely improved things in this regard. Let's now have a look at some taller prints to see if we can detect any print bed stability issues on the new rods or bearings. So for this, I've gone with a few vase mode prints. In vase mode with lighter colored filaments, I find that you can easily see print artifacts because the filament is somewhat translucent at only one layer thick. Now the only challenge with these tall prints is that I couldn't seem to rationalize how to decouple the effects from, let's say, a crooked lead screw, so Z wobble, from the actual print bed wobbling back and forth if the bearings and rods were loose. If you guys happen to have any good prints or methods to isolate these two effects from one another, I'd love to hear about them down in the comment section below. Now in my case here, the cylinder turned out looking very nice, and I don't seem to be having either of those issues. The walls are extremely uniform, and I saw no signs of Z wobble or print bed instability in this taller part. Now to be sure I didn't just get this favorable result with a round profile, I repeated the procedure with a square profile in vase mode. The more abrupt accelerations and decelerations in both the X and Y axis should theoretically expose some issues with print bed stability if those bearings or rods were loose. But in this case, the walls looked very uniform, except for the front left edge of the profile, which exposed a part cooling issue. This is something that I'd also seen in my video with the Ender 3 V3 Core XZ machine. The part cooling fans are directional, and it seems like there might be a small dead zone there with very poor coverage in the front left corner. So when the print head dwells in those corners as it needs to change directions, excess heat builds up and we get this puckering. But otherwise, all three other edges look very nice. The surface is extremely uniform, and I'm not seeing any signs of print artifacts that would stem from the print bed shaking, especially at the top of the profile where those effects would be amplified. And just for good measure, I printed the same profile in the twisted version, although I did slow it down a little bit to see if I could get rid of the puckering and lifting along that one edge. Now it looks like there was less heat building up in that one corner, and the part cooling fan was able to work more effectively. It's also had the effect of less violent shaking on this print. However, I'd say the quality of the rest of the print was the same as the square profile, as this doesn't seem to be an issue after the rod upgrade. And lastly, I decided to print some taller parts that had infill, and I went with these vertical wind turbine blades. They're a nice combination of curved surfaces with one sharp edge, and as the profiles extend upwards, you can see that there are some pretty severe overhangs. So I think this is a pretty interesting geometry that could potentially reveal any existing issues. But in this case, I didn't notice anything that looked concerning to me. All of the surfaces looked very exceptional, and I couldn't single out a particular defect that stood out or looked unacceptable. One thing to note as we come to the end of reviewing these test prints is that with these KE machines, they do not come equipped with the built-in accelerometers on the print head or on the print bed to perform input shaping. You have to purchase that sensor separately, and I have not gone through that process on these machines. So that'll be the next thing that I'll be looking into for this printer, and I believe you can get those sensors directly from Creality. In theory, it should make these prints look even better, but so far, I'm extremely happy with the results from the 10mm rod upgrade. So that's where I'm going to wrap this video up. Be sure to check out my website, embracemaking.com, where you can find other interesting upgrades for your printers like these magnetic flex plates, and of course the 10mm rod upgrade for the Ender 3 V3 KE and SE. And don't forget to subscribe so you don't miss all of the interesting things that I got going on this channel. Thanks for watching.